Ever had a memory leak because two objects just refused to let go? In Python, a regular reference keeps an object alive. As long as something points to it, the garbage collector leaves it alone. A weak reference is different. It points to an object without preventing collection. When no strong references remain, the object is freed and the weakref returns none. You create one with Python's weakref module. The classic problem weak references solve is circular references. Imagine a parent holding children and each child holding a reference back to the parent. Neither can ever be freed. That's a memory leak. Make the child's back reference a weakref and you break the cycle. This shows up in trees, event systems, and observer patterns. Weak references shine in caches. Python's weak value dictionary removes entries automatically when values are no longer needed, keeping your cache fresh. They're also ideal for event listeners, where you want subscribers to disappear naturally without explicit cleanup. One catch: calling a weakref like a function returns the live object or none if it was already collected. Always check the result before using it. Skip that check and you'll get a type error at runtime. Use weak references to observe objects without owning them. Break cycles, power caches, manage observers. But always guard against none. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.